Hi, welcome to the video lectures. In these lectures, I'm going to discuss about our program, and the goal is to provide a brief introduction to the key issues of our language. So our outline today is introduction to our. We will discuss about the historical development and the capability of our program, and also the stat analysis. So the first thing I want to point out in this slide is that we have a lot of references in our program. So again, you can hold down the control key on your keyboard, then click any of the reference. So I'm going to click the first one, which is an introduction to R, software for stat modeling computer. Now, first again, hold down the control key, then click on it, and that will take us to the reference. Again, all the references are online reference, so first you have to make sure that you're also online or you are connected to the internet. So this is my first again reference. And here we have some data set and also our script. And most important, we have some our lecture notes here. I'm going to open it, double click on it. It's a very good resources for our program. So this is an introduction to R, the software for stat modeling and computer. And basically it goes through how to use the R program. So it's more or less like an online textbook. It's almost 364 pages. So it's a e-book for free for the R program. Also, I'll go back to the second one. Again, the same thing, hold down the control key and click on it. I like the second one because it's more into the R graphics. Again, this is it. It's also a e-book, up to 11 chapters. And it focuses a lot on the R graphics. So again, we have, in this slide, we have like 4 or 5 different resources on R. So again, anytime you want to click any of the links, hold down the control key, then you click on it. So again, that's a very good materials for R beginners. So we know R initially was developed by Rose and Robert. Actually, that's why the language name is R. They used their first initial name to name the language. This was in the earlier 1990s. I will go detail here again. Everything is on the slides. Our main goal is how to use the R program. So there are some few examples. Again, in short, our program is used mostly for data analysis, and also it's used for data visualization. And R is a functional language. It's a functional language for mostly for, again, stat computation and graphics, which is data analysis, and also data visualization. So I'll go details on the hands-on aspect. Instead of typing, I'm going to copy and paste. So I'm going to copy log page 232. And this is my R Studio. So this is how the other R or R Studio is more like interactive. It's an interactive environment. So we can even use R as a calculator. For example, already started R, and when you start the application, I'm just going to type 9 plus 6 here, and it will give me 15. So we can do all the arithmetic operations on R. Also previously, I copied log base 232. And when I press and enter, it will give me 5. So here it's like I'm using R as a calculator. So as I said, it takes almost all the arithmetic, you can use all the arithmetic operations. R also come with a lot of packages. I mean, we have packages for example, computational biology or bioinformatics, which we call the bioconductor. And there are so many different packages for machine learning or data mining. We have packages for most of the algorithms. For example, decision trees, support vector machines. We have all the packages for, So the first I'm going to discuss here is that anytime we want to install a new package, first of all, we have to know the package. So anytime I want to install a new package, either you can use, it's up to you. You can either use the command by typing install packages. Then we have the package name. So let's say I want to install any package I can think of. Let's say we have the package for SQL, to use MySQL. MySQL is a database system. Now, if I want to connect my R program with MySQL database system in order to, again, get data from the database system, which is MySQL, I can import the R MySQL. That will make it possible for us to be able to connect. So I'm just going to type here R. Make sure I have the spelling right. R MySQL. Then I will just press enter. And this means, again, I'm connecting, and I'm trying to use again the R package. Yeah. So we have a message here saying that installing package into, again, that's my directory. So my directory is C, the user's name, my name is Charles, the document, etc. Okay, so that's it. I can see the message here, package R MySQL successful unpacked, and MD5 sounds check. The download package are in. So now I'm good to go. So now when you can see that I wait for a few seconds, or I'm sure less than 1 minute. I have to, when you want to, again, store package, when you use the command finish, you have to wait until the cursor starts to blink again. And here I have all the information that my package is installed. Now, if you want to know the packages that you already installed in your computer, I can just check it by typing again, install. Make sure I have correct spelling, install packages. And the argument, nothing. And it will give me the list. I think I typed something wrong. Oh, I typed the L 3 times. So install supposed to be double L, not 3 L's. So let me take my time, make sure I have correct spelling. Okay, let's make sure this is correct now. Okay, let's try it now. Okay, so these are all the packages that I have. Again, I have been using the R for some time, so I even use it for data mining, computational biology. So I have some package like HPO for computational biology, GO or genome info. When this is mostly the bioconductor I was using it for. So these are all the packages. Also, I use the Waker. Waker is a machine learning program, and it's also it's free, open source. You can download, but it's normally used for data mining and also machine learning. Like example would be classification, clustering, and the rest. But the reason why I'm going to connect R with Waker is that Waker is very fast comparing with R. So sometimes we may be doing like data mining or data analysis. Instead of running everything on my R, I'll be also using the Waker. So I'll connect Waker with R. And the package name is R Waker. It's very useful too. So this is one of the big advantage of our program. The packages are so many. We have so many packages that we can use. So, and also another option, this again produces a very long, we can say almost all the possible packages I have. And a more user-friendly, R is more user-friendly, especially if you know all the packages. I mean, not if you know the packages that you want to use. We can also use the library function, and that also will give us all the install package. So here again, I type installed period packages. Now I'm going to type only library. Again, the function name is library with open argument. And I press enter again. Just wait for a few seconds. Okay, so we can see the packages. So here it's telling the packages in library, the directory, and these are all the packages. Again, it's the same list of packages, so we can either use install the packages or function, or we can use the library function. Also, if you want, for example, R is always updating. There are new packages coming out always. So if you want to, if maybe, let's say I use a package for some time ago, I want to see if I can be able to update it. Maybe there's a new version of that package. First, I can check by typing old packages, old period packages, to see if I can get, if I have any list of old packages. Now I can see I have some few lists of them here on my screen. We can see. Now, another option is I want to update them. So I'll go to update the period packages. So update dot packages. This will take some time sometimes. Here it's telling me warning, package foreign library. We have a package. And the version is this available. So whether now it's giving the option. We have found an old package. So now should I update it? Yes, no. I will say Y, which is yes, and press enter. Another one, do I want to update also? I'll say yes. Again, this will keep going. It's not going to update all the old package at once. It will give you a message first, whether you want to leave it or maybe this one, I will say no, and I'll keep going. So what I did, I don't want to keep wasting going through. So if I want to cancel, I just put C. C means to cancel, updating the packages. So I only update like 2 or 3 packages. Then I enter C to cancel it. One thing also we should know is that everything in R is an object. And the concept is like object-oriented programming. So there are 2 main concepts behind R language: objects and functions. The objects normally can be seen as a storage space or memory, which we normally associate with a name. Then we know functions, almost every programming language, a function normally perform a task. The functions perform a task. So everything in R is stored in an object. Even the function also is stored in an object. The variables, the data, everything, files, everything stored in an object. So let's do some, I'll just play with the program, not really play, but again, just some basic stuff here. Let's say I want to enter, I want to create, one thing with R also, we don't need to declare the variable. So we know, for example, C++, Java, if I want to use any variable, I'm going to declare it first. R is the same as Python. I don't need to declare the variables. We have 4 different types of variable, either numeric, it's a binary number, or complex number, or character. So these are the 4 major. It's values or strings, characters, or it's true, false, boolean, or it's a complex value number. So here I'm just going to do some few, and this will take just a few minutes just to play with this. So for example, I want to store any value at enter x equal to 90. This means I'm storing 90 into a variable named x. Or we can also use an arrow. We can use an arrow. So here what I'm doing, I'm storing, oh sorry, I have the arrow opposite. So the typing. So what happened here? I have 90. I keep the same 90. Now, if I enter x, which means I want to know the content in the variable. But most of the time, I always use equal because using an arrow, when R came out first, arrow is what we normally use to. This arrow is like the assignment operator, but again later on equal sign. I prefer using equal sign always. The reason why, because it's only one key. I don't want to type the left arrow in a dash twice. That's 2 keys. But again, we can use either one. And one thing also, for example, is same as any programming language. I declare variable x, I assign 90 to it. Next time, if I assign different value, let's say 7 or 8, what will happen is that it is going to overwrite the 90. So now the content of x should be 8. And I don't want to take too long here. Again, we can do plus, minus, for example, times 45, 9 times. Is plus multiplication is the asterisk. Plus multiply, addition, subtract. We can do all the arithmetic operation. And also the modulo. So for example, I can say 7. Yeah, so. Oh, I have 2 colors. So I can have like 6 square. So a carat operator means square. I want to enter the carat and I enter percent. Again, the carat is 6, percent is 5. So those are the, again, as time goes on, go through the R resources. Again, you will see a lot of tools that we can use, features in our. So the first thing I'm going to mention here, which is more important, is what is a vector. In R, we have something like a vector matrix string. This is how we store data or how we organize data in an object or storage place. The most basic data storage is the vector. So I'll say the most basic data object in R is a vector. We can assign only one single value to a vector, or we can use a function called a C. C means to combine, to assign more than one value. Also, we can use the length functions to know how many elements is in a vector or a matrix. So the length of an object is the number of elements in it. And we always can use the element function, the length function, length function. What I mean is, this is, maybe let me type it here. This is a length function. This is the function we can use to, again, know how many items or elements is in a function. And normally the argument, actually, let me use this. The argument is where you have the variable name. So I have X, and this will give me 1, because X have only one value. Now, if I don't have any object or I haven't used any object, let's say I have length, let's use maybe R or W as our object. I will surely get error, because why? We don't have the object name W, so object W not found. So let's, for example, we have only X, one element. Now, if I want to have more than one element, I'm going to use a function that can combine, which call it C or combine function. So for example, I have a variable, let's declare a new, let's say Y, we have X already. But again, we can, as we said, we can overwrite it. If I want to use X, I can use it again. So here, for example, I will say C, that's the function name. Then all my elements will be here. Let me use values. Now, if you are using the characters, they have to be in at least a single quotation or double quotation. So that should be enough. We have 4 values. So this is okay. Now, if I say I want to know the length of this, again, it will give me 4. So we get 4. So there are 2 things we have to know about an object, other than length of the object, which is the number of items, elements or items in that object. Or we also have to, if we want to know the mode means we want to know the type of item inside that variable. So here, let's say variable Y again. So I say mode variable Y. And it said numeric, which is right because I have values. So the mode is like you want to know the data type of the items in that object. So for example, let's try to declare, let's say variable name J. And this time we are going to give it a characters string. Let's type only 2 again to waste time. So this means we have an object named J or variable, and we have 2 items in, but we don't know, let's say we don't know the data type. So I'm going to use mode J. and it says a character. Again, we have it in a double quotation or single quotation. And the same thing, if we say the length is going to give us 2. It's going to give us 2. So the same thing, we can do addition of 2 values. Let's say we have x and y. X was only 1 value. Y was 4 values. But I can also still add the 2 items together. But what will happen is that when we add them, well, let me type what I'm trying to say. For example, I can say s plus y. And what happened? We will see that we have 12, 13, 14, 16. And the reason why, because we have x is only 1 value. So we use that value to add all the values in there. So let's see what value was x. S was 36. No, not 36, sorry. S was 6. Yeah, no, S was 8. You can see S was 8. The last value of x is what I'm looking for. So if S is 8, 8 plus 4 is 12. 8 plus 5 is 13. 8 plus 6. Then 8 plus 8, 16. Again, this is some few rules. Because x is only 1 value, we are going to add the 1 value to all the elements in y. Now, let's say if x should be, we're going to get a new x value. So I'll start with x equal to, let's give it exactly 4 values. Oh, well, let's try with 2 first. See what will happen. Now we have 7 and 8, but y is 4 values. And I'm still going to do s plus y. And we can see what is going on here. So again, y was, this time x is 7. So 7 plus 4. Again, we know y, we still can go back and see the y value. This is the y. So y value is 4, 5, 6, 8. And we can see what is going on here. So 4 plus 7 is 11. Then what happened? We didn't take the 7, we take 8. 8 plus 5 is 13. If we have a third value, like it's going to add a third value with the y third value. Fourth value with 4. But since we don't have it, it will start from beginning again. Then we say 7 plus 6, 13. Then 8 plus 8, 16. So now what I'm trying to explain here is that if I have only 1 x value and I have 4 y value, I will use that 1 value to add everything for the 4. Now, if I have 2, I'll add the first one to first s and first y, second s and second y. Since we don't have third y, then we start all over for first s again. So since we don't have the third x, but we have third y and fourth y, we start with the first x again to third y, then second s to fourth y. The same thing if I have 3 values, it will add all the first 3, okay. Then since I don't have the 4 value for x, I'm going to start add the first value of x to the 4 value of y. So again, that's how when we are adding object with more than 1 element, that's how it works. Until some of us know what is called an array. An array in any programming language normally consists of values that have the same data type, and of course, the name will be the same also. This concept, I would say, is kind of like an array concept when we use the C. So also, we can assign, so far I didn't assign string, but let me just do this. For example, if I want to get the value, let's say I'm going to type x square bracket 2 and see what will come. We get 8. Why? The concept of array index. So x is 1, 7 is 1, 8 is 2. So S2 means I'm going to access the second value of x. And the same thing we can do for y, etc. Now, if I want to, also we can assign, I don't know if you assign no string, maybe I can assign a string value or a character. Only this time I'll make sure it's in double quotation. This is correct. Also, we can create an empty vector. We said what we have right now is a vector. A vector normally is the most basic R object. So we said a vector is the most basic data object in R because a vector can consist of one or more elements. There's no level of it, there's no keys or hash. When we talk about frame, we going to factors, we may talk about the levels, etc. So here also, I can create an empty vector if I want to. And all I have to do is, let's say we want to create empty vector. We have a variable named u, and I have to use the vector function. So I will say vector, everything lowercase, and press enter. So right now I have an empty vector, and it's u. Now if I want to know what is u, u is a variable. U is there's no error. We create u, but there's nothing inside u. So the length of a vector can be changed by simply adding more elements to it using previously non-existent index. What we mean by here is that, for example, right now, x is what? We have x is only 2. Now, what I can do is that I can say, okay, x 6 equal to 9. X is only 2. The next value should be 3, but I went straight to 6. This will work. Now, if I want to know the length, spell it correct, length. I didn't spell it correct, so length supposed to be TH, not HT. Okay. We want to know the length of X. So we can see the length of X is now 6. Why is it 6? First, we have only 2 values. By the second, what I did is that I assigned 9 to the 6th element. So which means now I have 6. But what will happen is that 1 have a value, 2 have a value, 3, 4, 5 will be NA. We don't not no value. So let's say, for example, I enter X. I want to know what is in X. We can see the first we have good, then the rest is NA, right. Then the last value. Now you can see, because the first value, previous class said 6, I was using the old value. If you look here, we assign GGOD to X. So X have a new, it overwrites the previous value. So because one value is a string or character, it automatically makes 9 also a character or string. Even it's a value that we enter, but it becomes a string. So one thing, there are so many we can go through some of the functions here. Let's say, for example, what can I do? Let's say we want to find the square root of a value. So the function name is square root, and I'm looking for square root of, we cannot look for square root of x no more, because x is not a values. Well, let's put X and you will see what I'm trying to say here. See, I get error. Why? Because it's non-numeric argument. We can only find square root of a value, a numeric, not a string or a character. So I can have square root. I think U was okay. If we have U, no, there's nothing in U. Then let's see Y. I think Y, there was a value in Y. There's a value in Y. I can't remember here. So the value of Y, we can see that we have 4 values in Y using the C function. So we can see that again, we have 4 different results. Again, my main goal of today's lecture is just to go through the basic concept of, again, R. That as time goes on, we may start to use some of the packages for data mining, data analysis, and also visualization. Actually, all our assignments, most of the assignments will be hands-on using R, and that we are going to analyze the data or visualize the data. So my next lecture in R, we may again talk about more advanced stuff in data analysis, still data mining or data analysis. So let's move on forward. Again, the best way of doing this is to go through our textbook doesn't cover anything about R. So that's why the first slides I have, there's a link. I will go through that link one more time before I stop this video. If you have, again, the resources, again, you can purchase any R program. One of the cheapest R book I know right now is the R for Dummies. Maybe most of you know the Dummies textbooks. It's very cheap. It's a good price. And it covers almost everything about, at least the average things you have to know about R, coding, visualization, how to use some of the packages, etc. Also, there's another textbook, R for Biology and Medicine. Again, in my next lectures, when I make a slides, I'm going to post all these textbooks in the slides so you can get the idea of them. So we finish with vectors. Now I want us to move to the next, which we call the factors. The next data object in our. So factors also provide an easy and compact form of handling nominal data, categorical data, and it makes this by levels. So factors have what we call levels that are possible values they can take. So factors are particularly useful in data sets when you have a categorical or nominal variables with a fixed number of possible values. And we know that there are so many graphical and summarization functions that use, again, factors. Because, again, factors allow us to use and show the values of your nominal variables or the categorical variables. So let's see how we can create a factor. So, example, when I say a factor, I'm going to type it here. This is what I mean by, again, this is an error, and I'm not doing anything. So this is called a factor. And also a factor, as I said, normally provide, I would say, an easy and also compact form of nominal data or categorical data. And they have what we call the levels. So let's see how we can. So the first thing I'm going to do is to create a vector, any vector I can think of. So let's say I will name it G. And we should create more than one. So I'll use the C. And then since a vector, let's create some strings or characters. State F. Um, anything, let's say M, G. When you use a double quotation, I can enter more than one character. When I use a single quote, it should be only one character. So most of the time, I just like to enter double quotation. And I think this should be enough. So right now I have what we call a vector with three elements, and the elements type is non-numeric or characters. And now when I enter G, of course, those are the four characters we have. Now I want to transform this vector into a factor. So I have G. So remember G equal to, that's where the vector is. Then we have to use the function called the factor and also G. I decided to convert or create the G factor, create a G a factor name G from the vector G. But we can change the variable. I can say, okay, I'm using the factor G. I'm using the vector G to create a factor, and I'll assign it to, let's say, X or K. But this is okay also. So right now our G is no more a vector. It's now a factor. How do we know? So let's see. I will enter G. It will show us the levels. So G have how many characters? F, M, J, K. F, M, J, K. And the levels are what? F, J, K, and M. So again, that's the whole concept here. Okay, so that's the whole concept of factor. So one thing we should mention, here we say the elements are four, the levels are four. Why the levels are four? Yes, because we have four different characters. Now let's try one more example. Let's say I'm going to have G, or let me create a new, let's say H equal to, I'm just going to give it, we have three Ks. Let's add one more K, one more again, then L, another L. Okay, this should be enough. Then let's do the same thing we did before. We are going to change this H to factor. Now, I want to know what is H. You see that the level will be only 2. So here the levels are K and K and L. So again, that's the whole concept of a factor. And later as time goes on, we will see why we need factors in our program. And one thing also, you can say that when I enter let me take my care. When I enter the J as a vector, when I want to view the content, it's what? It's a character, double quotation. But when it's a vector, when you want to view the content, you can see that there's no double quotation. So here we're trying to say that a factor has something we call like a built-in numeric system. So internally, the FMJK will represent as what I mean here. FMJK, the factor, will be represented as 1, 2, 3, 4. Because the levels we count level 1, level 2, level 3, level 4, kind of characters. So let me go back to the slides. So again, there are so many things we can do with R, and I'll go through more lectures on it. But as I said earlier, let me go back here again. As I said earlier, these references are very, very good, especially if you are not ready to purchase a textbook or material. These are all ebooks, and they are also online for free, the PDF in PDF format online. So try to get at least one of them. I would prefer the introduction to R, the last one. I like the last one. And also using R for data analysis and graphics. This also is very good. So as we said, we talk about the R, which initially developed by Rose and Robert. Actually, that's where the initial name, the name R came from. They used their first initial name. And R also is open source, free. We have graphical capabilities, arithmetic operations, any possible operations, many packages that we can use in different computing, both statistics, computational biology, mathematics, data mining, analysis, etc. And what makes R very famous again is because it's more user friendly. The steepness of learning is very, the learning curve is very low. It's easy to learn, especially if you already know how to use, for example, SAS, SAS, or SPSS. Learning R will be more easier. Or if you know any programming language such as Python, C, or C++. It's also a high-level data analytics. And also it supports the classes, object-oriented concepts. With R, I can also write my own, create my own class, write my own methods, and do any computation I want to do. So it's an object-oriented program. It has the looping, decision-making. It's said as any programming language. And packages that make it possible for us to get files from Excel or database system like MySQL, etc. The packages, as we said earlier, R is very good. It has most of all the statistics packages. For example, finding the basic mean, median, mode, standard deviation, regression analysis, ANOVA, hypothesis testing, reactive testing. They all have all the packages for most of all the statistics computations. And that's what we mentioned here, data analysis and presentation. Again, this slide will be posted in in the week two folder in the content tab. So you can go through the slide. Actually, I have to post this slide because the references, the resources in the first slide, very important. Again, as I say, you click the control, press your control key on your keyboard and left click on the link, and that will take you to the resources. So as we said, R is like a calculator. We can use it for calculations. I can find log base 232. That should give me 5. Square root of 2 will give me 1.414. And also if I need values, here we say we need this is like sequential. If I need values from 0 to 5 and the length is 6, then it will be 0, 1, 2, 3, 4, 5. And when you count this, the length equal to 6. So I want to create a list of items. I didn't do this. Actually, let's try this and see. So this is using the plot function. And I want to plot a function. This is a sine, like trigonometry sine. I want to plot a function that the equation is sine from the value. Again, here I'm creating values. So the values is sequential from 0 to 2 times power. 0 to 2 times power. And the length is 100. The length is 100. So we can see here the equation sine sequential 0.2 times power, length of equal to 100. So then there's the horizontal becomes from 0 to 100. And the sine equation is 0 to 2 times power. So I'm going to, let's copy this. I don't want to type it. And then we go to the arrow again. So I'm just going to paste it right here. Make sure everything is correct. Yes. So I press enter. Let's assume I just type this. So what I'm doing is just using only the plot. Actually, I have it here. I did it before. So we can see the result right here. So here we are using the plot function to plot. So when you are plotting, the content inside will be x and y values. So we have x horizontal, y. So the object orientation, as we said, R also is an object orientation program. Object is normally a collection of variables. Normally, a class consists of methods and objects. So example here, we say object is a collection of atomic variables or other objects that belongs together. So example given in a microarray experiment, the probe intensities. Patient data is again an object. So we have a patient, an object. We can have the tissue location, the diagnosis and follow-up, which will be the attributes or the characteristics of the object. We have a gene data. We can have the sequence and also the ID of the gene and also annotation. So a gene data is an object and the characteristics of an object or the attributes in the sequence ID. For example, a person is an object. Person, last name, first name, social security number, address, these are all the characteristics of the person. So we're going to end somewhere here, and I will surely continue on this slide, hopefully by Saturday. So again, if you have any question about the R program or about the course in general, again, you can reach me at 917-627-8255. 0024. Or you can also send an email. So again, wish everybody the best, and thank you.